Hi, my name is Chengkai Li. I'm the principal investigator of one of the projects funded by the National Science Foundation Proto-OKN program. Our project is SOCKG, a knowledge graph informing soil carbon modeling. This work is a collaboration between the University of Texas at Arlington and the United States Department of Agriculture, Agricultural Research Service. Today, I'm going to give you a brief overview of the project. Just a bit of background information to start this overview. The carbon cycle is the process by which carbon is exchanged among the atmosphere, oceans, and land. Soil is the largest terrestrial carbon sink, and it contains more carbon than vegetation and atmosphere combined, positioning soil as a key player in global efforts to reduce greenhouse gas emissions. Carbon sequestration in soil is the process of capturing and storing atmospheric carbon dioxide within the soil, helping reducing greenhouse gas levels, improve soil health, and fight climate change. Experts have identified various agricultural management practices that sequester carbon or reduce greenhouse gas emissions. For example, planting cover crops such as clover or rye during the off-season helps protect the soil from erosion, increase organic matter, and enhance microbial activity, and capture atmospheric carbon in the root systems and soil, thereby improving soil fertility while sequestering carbon over time. In the SOCKG project, we developed a knowledge graph, a semantic infrastructure designed to support robust and user-friendly soil carbon modeling. The primary objective of this project, of this knowledge graph, is to aid the investigation of factors influencing soil organic carbon dynamics and other critical soil measurements. The project provides a set of tools for querying and analytics by aggregating and aligning diverse data sources across different time periods and geographical locations. This knowledge graph and its associated tools can be useful to a wide range of users, including farmers, researchers, and policymakers. You may wonder how it benefits farmers. Farmers can earn carbon credits and generate revenue by storing carbon in soil, allowing them to participate in carbon markets that offset emissions from major industry polluters such as energy, transportation, and manufacturing sectors. So our work serves various purposes, including research support, policy formulation, and even education and training. Beyond the carbon market, it can also support broader applications such as food security, land use planning, and environmental management. Our primary data source for building this knowledge graph is across the Agricultural Collaborative Research Outcome Systems repository from USDA. Across is essentially a network of networks. In this figure, you can see a map of various sites color-coded by their respective networks. Our project specifically focuses on the GraceNet network and selected sites from the READ network, as they contain carbon-related measurements relevant to our study. Let's take a look at the three most important elements of this dataset. The first key element is the definition of experimental units. In this figure, you can see a map of one of the USDA study sites. There are 5 large rectangles. Each represents a block. Each block contains several plots, shown here as the vertical rectangles, and each plot is made up of 3 subplots, represented by the smaller squares. These subplots are the experimental units where various treatments are applied and where soil sampling and different types of measurements are conducted. What do we mean by applying a treatment to an experimental unit? In this context, each treatment is a combination of a nitrogen level and a cross rotation. The nitrogen level can be one of three categories: 0, no nitrogen, low, or high. The crop rotation component includes both the rotation length and the sequence of crops grown. For example, a corn soybean 2-year rotation means that corn and soybean are grown in alternating years, corn 1 year and followed by soybean the next year. Another important element of the data is the measurement and the samples. Soil samples are taken at different depths, each defined by an upper and a lower depth boundary. Each soil sample measurements For each soil sample, measurements are recorded, capturing the sample's chemical, physical, or biological properties. For example, one measurement might indicate the pH value of the soil in that specific sample. Here you can see an overview of the SOCKG ontology showing the classes and object properties. This is actually a screenshot from the Interactive Ontology Explorer, which is a tool we developed in the project and made available on the project website, where users can click on different components to explore detailed information. This will be further explained in the technical video. The SOCKG knowledge graph comprises over 4,000 experimental units across more than 60 study sites and tens of thousands of different soil samples. In this table, you can also see the number of classes and the properties in our ontology, as well as the number of instances for each class. For the classes, object properties, and data properties in our data graph. The project has contributions from a team of researchers from the University of Texas at Arlington and USDA ARS, including postdocs, PhD students, master students, and undergraduate students. Thank you for your attention.